Alright, so we're doing more of the same stuff from yesterday. So this top part is just reminding you that anytime it asks you for solutions, root zeros, x-intercepts, they're all the same thing, right? So all those mean the same thing. They want you to find where you cross the x-axis, yes? And we did that in your calculator yesterday. So number one wants to know the zeros for this function. So how are you going to find them? Put it in your calculator. Because if you look at this, we're trying to find factors of 10 that subtract to be 6. Are there any? No, so that's why you've got to use your calculator. Does that make sense? It's like the bell ringer, everything factored nicely, and we could do it by hand. It was awesome. These are going to be decimals, so you've got to use your calculator to find those zeros. And wants you to round to the nearest hundredth. So how many decimal places is that? 2. So we're going to go in our calculator and we're going to type in what on a new graph? What do you got? What do we type? What do we put? What are I can speak this over so I can see it. What are you typing in? Did we put the equals 0 part? No. Don't put 2 equal signs in there. You already got one. That's enough. Alright, so, I hate that this reflects the light so bad. Is that better? Okay. How are we going to find those roots, or those zeros, or those solutions, or those x-intercepts? Menu. Analyze graph, and we're choosing zeros. You got to do the 2 individually. Make sure you click on the left, scroll over, click on the right. You'll have to do it twice to find them both, yes? So go find the other one. Same steps again, menu, analyze graph, 0. For those of you that weren't here yesterday, is this making any sense? Are you finding these things? You okay? Or are you lost? You okay? Okay, if you got questions, let me know, because we're moving quick. We did this all yesterday. Michael, you okay right now? Alright, so what are our zeros? Negative 7.36 and what else? 1.36. Is that okay? Questions? So we're all right? You're not telling me anything, so I'm assuming that you're good. You good? Okay, I mean, I'm just seeing tops of heads. I guess that's because you're just working so hard? Yes. Yeah? Okay. For number 2, before we can put this in the graph to find our solutions, what are we going to have to do? Move that 3 over. You still want it to equal 0, even though we're not putting in equals 0. We want everything on the same side. So in your calculator, you should be typing x squared plus 4x plus 3. Is that okay? So go to a new graph, type that in, find your zeros. For this one, could we do it by hand? Are there factors of 3 that add to be 4? Yeah. So you could do this by hand if you wanted to. You don't have to. We'll do our calculator. So remember, you've got to do them one at a time. So make sure that when you draw those lines that you're going around the 0 that you want. If you highlight the whole thing, it's only going to find one of them. And that's okay. You'll just have to go back and do it again later. So you're going around where you think that 0 is happening. And it's a little hard to read what they are on here, but can you guys tell what the zeros are? -3 and -1. Is that all right? Questions? You're still good? Yeah? You're still good? So, for number 3, we want to know the roots. What are you going to have to do first before you find those roots? You can move the x squared over. You can move the other stuff over. Doesn't matter a whole lot. So we're going to say negative x squared minus 7 plus 11x. That's what you could type in your calculator. Is that the order that we like it in, usually? No. Does it matter for your calculator? No. It'll give it, or it'll do it however you give it to it. So it'll be fine there. Yeah, so we'll just go to a new graph, type that in, find our zeros. We'll be good to go. Is this still pretty easy for everybody? Anybody got questions or anything we're not sure about? We're doing all right. So for this one, can we see both of our zeros? No, you got to zoom out. So to zoom out, remind me how we do that. Correct. Zoom out or zoom in. Either one you want to pick will be fine. I like zoom out better, but that's just me. So now I can see them both, so we're good to analyze your graph. So it wants you to round to the nearest hundredth. So for that first zero, what are we going to round that to? 0.68. Is that okay? Then for your second zero, what was that one going to be? 10 point what? 10 point what? 3. Okay, okay. I thought I heard somebody saying 4 earlier. Are we okay with those? Now your calculator, when you do the analyze graph here, it'll only go so far. So like I'm sure there's another decimal behind that 3 with the 10, but it only gave us the 3, so we're going to stop there. Does that make sense? So you can just write whatever it gives you, and you should be okay. Then for the last one, what do we have to do here before you can find your solutions? Add 8. Yeah? So in your calculator, you should actually be writing x squared plus 2x plus 8. And find your zeros from there. So, did you guys get it graphs? So what happened? Can we see it?
Maybe it's so big.
Maybe it's somewhere else. So how could we test that? Let's try zoom fit. See if that helps us out here. Okay, we can see our graph now. What do you notice? Never crosses your x-axis. Is that okay? So what do we put for as far as our zeros or our solutions? None. Is that all right? Okay. Alright, so for the next one, we got a football, and it's kicked up from ground level at an initial upward velocity of 20 feet per second. The function right here gives your height of the football after 2 seconds. So we've got step by step what it wants us to do here. So step A is to graph the function. So we're going to go to a new graph in our calculator, and we're going to graph that function. Can we put t's in here? What do you put instead? X's, so negative 4x squared plus 20x. So we've got our graph. Everybody graphed? So remember, anything I'm doing, you're doing. Yeah? You gotta know how to do this. It's too easy to not learn how to do this. It's all in the calculator. So next it wants to know the height of the football after 2 seconds. So what are you thinking? What can we do? We want to know height. So is that x or y? Y. After 2 seconds, in 2 seconds, that's your x, right? So when x is 2, what is y? How can we go about figuring that out? You could plug in 2. What'd you say, Ashley? What do you mean? We would do that if y was equaling some number, and we wanted to see what x was then. But since x is just 2, and we want to know what y is there, can we just look at the table? Do you remember how to pull up the table? Control T. The table's already made for you. So these are the values that we would get if we went in and plugged in all those numbers, right? So if we plugged in 2 by hand, what would you get out? Before, I think that was a lot easier, Control T, than having to plug in all those numbers. Do you agree? So, after 2 seconds, what was the height of the football? 24. And are we in feet? Does it tell us we're in feet?
Yeah.
So we'll put feet. Is that alright? So for the next part, it wants to know when the ball is 16 feet high. So when wants to know x, and it's giving us a y, a height of 16. So how could we figure that one out? If it's good numbers, you could tell from your table. If it's not good numbers, we're going to have to do like we did yesterday, where we put in that extra line at 16, like Ashley was saying earlier. So we type in 16 and see where it intersected. Can you find 16 in your table, though? Where does that equal 16? 1. Does it ever happen again? Where? At 4. So at 1 second and at 4 seconds. Ooh, bless you. Is that all right? Yeah, no, maybe? Questions? Okay. So the next part, it wants to know the zeros, or your x-intercepts of the function. So I'm going to get out of the table because we don't really need that anymore. So I'm going to do Control T. That'll close it for us. And we want to know your x-intercepts, or your zeros. How do you find them? Menu, analyze graph, and we're choosing zeros. So can I show y'all kind of a cheat? So you don't have to do it twice. So if you like hover, do you see how it's already recognized that 1 0? Yeah? So we know that one of them is at 0. If you keep going, oh, just kidding. Sometimes it works. It'll pick up the second 0, and you can do them both at one time without doing it twice. Never mind. I'm going to have to do it twice. I thought I had something cool figured out. I don't. What's up? Did y'all hear what Jacob said? Through the middle, and then go left and right. You can do it at the same time. So that'll work too. Anyway, it's not too hard to do it individually. Alright, so where do your zeros, your x-intercepts happen? So the zeros are at 0 and 5. What do they represent in this problem? So here's our graph. There are zeros. And we're talking about a football being kicked. And coming back down to that. So what are those zeros? Where it's what? Where it lands. And that would be the second one, right? What would the first one be? Where it's what? Where it's kicked, right? You're kicking a football. So it's where it's kicked and where it lands. Or when it kicks and when it lands. So we'll say when it kicked and when it lands. So do y'all remember that phrase yesterday that tells you to look for zeros? Hit the ground, right? And these points are both where? In the ground, right? It's on the ground when you kick it, and it's on the ground when it lands, right? So anytime you're talking about the ground, you're thinking zeros, or x-intercepts, or roots, or solutions. Is that all right? Yes, maybe? All right, so the next part, it wants to know the maximum height of the football and when it is reached. So what does that want you to find? Your maximum, right? So how do we do that? Menu, analyze graph. What are we choosing this time? Maximum. So just make sure that you're clicking somewhere on the left and somewhere on the right. And it'll zoom out for you, even though we can't see where it's at. It'll zoom out as far as we need to go. So where does that vertex or that maximum happen? 2.5, 25. So what does that mean? So it's 25 feet at 2.5 seconds, or you can think of it, it's going to take 2.5 seconds to reach 25 feet. So I'm going to write that out because I think that's makes us sound smart when we say it that way. So it will take 2.5 seconds for the ball to reach a max height of 25. Okay? Yes, no, maybe? Questions on anything? So we're still okay? Alright, so the last part there, how long was the football in the air? How did you figure that out? You get your zeros and subtract them, right? So if we started, we kicked the ball at 0 and it landed at 5. So how long was it in the air? 5 seconds. Is that okay? Any questions at all? So looking at the next one, I think y'all can do that one all by yourself. Y'all want to try it? Are you ready for that or no? Try it. There's going to be a little bit different. So here's your function. It's modeling the height of a baseball that's been hit by a bat. So when you hit a baseball, are you hitting it from the ground like we kicked that football? Where is it going to be? Coming at you, right? So somewhere in the air. So when you start, what time is it when you start? Or when you hit that ball, what time do you think it probably is? 0, right? So if we plug in 0 for time, what do you get out? 0 plus 0 plus 5. 5. That's your y-intercept, right? So your y-intercept is when time is 0. When you start, it's 5. So that tells you that you hit the ball at what height? 5. Does that make any sense? So I think it asked you for that. That's the last part. From what height did the bat hit the ball? That would be 5 feet. That's just asking you for your y-intercept. So I would jot that down. It's a question you will probably see again or be asked again. So if they're asking you from what height did the bat hit the ball, from what height was it kicked, from what height did it fall off a building, whatever, that's what's your y-intercept. Okay. I think everything else there we talked about. For C, it wants to know how high above the ground the ball will be after 1 second, 2 seconds, 3 seconds, 4 seconds. So where could you find a bunch of those numbers? In the table. So let me ask you something. If you hit this ball and it hits the ground and your table starts going in negative numbers, is your ball going to keep going down into the ground? No. So what's going to happen when it starts going negative? What's your height? Really? 0. Okay, so keep that in mind. I think the rest you'll be good, so I'll give you like 3-4 minutes to get this done, and we'll go over it in just a second. Alright, so for the first part there, how high above the ground will the ball rise? What does it want you to find? Your maximum, and it wants to know how high, so is that the X or the Y? The Y. I grabbed it wrong. So what was the max height that it went to, Sonia? 105. Good. That what y'all got?
Yeah.
Awesome. How long did it take to get there? Ashley. 2.5 seconds, y'all agree?
Yeah.
Awesome. This was feet, is that correct? Then how high above the ground was the ball after 1 second? You're looking at the table for these values, correct? So Abigail, what was it after 1 second? 9. It's not here. Michael, what was it after 2 seconds? 101. Good. Thomas, what was it after 3? Good. And after 4 seconds, Bailey, what'd you get? Good. Are we okay with that?
Yeah.
Questions at all? All right. So after the ball was hit, how long was the ball in the air before it hit the ground? When you see hit the ground, what are you thinking? Zeros. So it's asking you to find what? Your zeros, right? So what was your zero? When did it hit the ground? Jacob, what'd you get? Does that make sense? Did it hit the ground at 0.06? So, y'all, your ball is like hit, goes up, comes back down. The first zero happens like here. We need the second one. So you gotta like zoom back in if you zoomed out for the match to find that. That's 5 point. Did you say 5.06 or 0.06? I'm sorry. I heard 0.06, just 0.06. I was like, no, that's wrong. What's up? I need a pass. Do you have passes? So I never gave you passes. Does that make sense to y'all, that 5.06? Sorry, I heard the wrong number, so I was confused there. That's my fault. So we'll move on to the next one. So we're going to fast. What are we talking about there? Oh, this is the box. I like these. So you had a few of these on your homework last night. So I hope they're not too bad. So we need to find the area of this rectangle. And it tells us that it's 170. Then we want to know the perimeter of the rectangle. So you've got to find what the side lengths are before you can find the perimeter. Do you agree? All right. So step one, we're going to write an equation for the area. So how do you find area? Length times width. So we're going to do 2x times what? 3x plus 2. And what does it tell us that the area is supposed to be? 170. Is that okay? So we could solve this equation for x, and that'll help us find out our side lengths. Do you agree? All right, so what do we have to do first here? Start solving. So it's 2x times 3x. 6x squared, and then 2x times 2. Then minus 170, because we want the whole thing to equal 0 so that we can factor and solve. Is that okay? Anytime you've got an x squared in your equation, you probably want everything on the same side. We're going to want to move everything over and try to factor and solve from there. So when you're factoring, what do you always check for first? GCF. Do we have one? Are you sure? Are those all even numbers? What could you at least divide by then? So let's do that. What is 6x squared divided by 2? And what is 4x divided by 2? And what's 170 divided by 2? What's it? 85? 85, yeah, that makes sense. Okay. Are we alright with that? So from there, how are we going to try to factor? Rainbows, multiply that 3 to the back. So we're going to be dealing with, I'm coming up here because I've run out of room. X squared plus 2x. Then what is 85 times 3? 25 times 3. So I don't know about y'all, but I definitely do not have factors of 255 memorized in my head. Do you? So how can we find factors of 255? Yeah, exactly. So we're going to go to our graph, and we are typing in the number we want factors of. So 255 divided by x. We'll hit enter, and we don't care what the graph looks like because we want to see the table. So Control T. So I'm going to go ahead and get our parentheses set up here. So we're going to do drop it low. You'll drop your x's, keep your first sign. Second sign's a minus, so they need to be opposite. We're looking for factors of 255 that subtract to be 2. So since they subtract to be 2, that means they're going to be pretty close numbers. So you're probably going to have to scroll a ways before you get some that are closer to each other. So I think I found them. 15 and 17, does that sound good to y'all?
Yeah.
Alright. So we'll put the 17 first, then the 15. What do you have to do from there? Divide by 3, because that's what we multiplied in the beginning to get us into this mess. So 17 over 3, will that reduce? Nope, so that's going to give you 3x plus 17. And then 15 over 3, will that reduce? What do you get? X minus 5. Good. From there, what do we do? Set them equal to 0 and solve. So from the 3x plus 17, what do you get? Good. From the x minus 5, what do we get? Positive 5. So now these x values, they're talking about a box, right? A rectangle. So it doesn't make any sense at all for the length of our box to be negative 17 over 3. No, that's not going to work out because it's negative. So whatever your negative answer is, throw it out. That means x has to be 5. Do you agree?
Yeah.
Are we done? Failing here. Is it like super important? Okay, alright. Rylan, they need you again. Alright, so we got 5 for x, yeah? So we can plug that back in and then we'll know the dimensions of our box. Does that make sense? So what is 2 times 5? 10. So that means that one side is 10. That means the other side over here is also what? 10. Now I'm labeling all the sides because we want to know the perimeter as our final answer. So it's going to help us if we have all those things labeled. Then we're plugging in 5 for the other side. So 3 times 5 plus 2, 17. And that means the other side is 17 as well. So we could check that. We know that our dimensions are 10 by 17, and they told you that your area was 170. So is 10 times 17 170? So that checks out. So that means we've probably done all our math correctly, which is good as far as we've gotten. I would hope we've done our math correctly. Then your perimeter, how are we going to find that? All your sides. So 10 plus 10 gives you plus 17. 37 plus 17 more. 54. Yeah? Yeah? Is that all right? Okay, so we'll say perimeter, P-E-R-I-M-E-T-E-R. Questions there? So we're all right? Number 4 is a lot like the ones that we've been doing. So is it okay if we just skip that one?
Yeah.
Okay, it's just more of the same thing over and over again. I feel like I've kind of got the point by now. So 5 and 6 are a bit different, so I do want us to do those. So it says that the longer leg of a right triangle is 2 centimeters longer than the short leg. So I'm going to pause right there. What should we be doing? What's that? Oh, I'm sorry. Up here. Yes. Yeah. Yep. Are we okay to skip that? Does anybody want to do that one? We can come back to it in a second if we need to. But number 5, it was talking about a right triangle. So what should we do right now? Draw a right triangle. So I'm going to draw my right triangle over here. It tells you that the long leg, so what is a leg of a triangle? What does that mean? Is it the straight sides or the slanted side? There's straight sides. What's the slanted side called? What's that word? Hypotenuse. Do y'all remember that word, hypotenuse? So your hypotenuse is the slanted side. It's the longest side. It's always going to be the one across from the 90-degree angle. And your legs are the other two sides. So it says that the long leg is 2 centimeters longer than the short leg. Do we know what the short leg is? So what do we put to hold its place? X. If the long one is 2 centimeters longer, x plus 2, then it tells you that the hypotenuse, that's our slanted side, is 4 centimeters longer than the short leg. How do we write that? X plus 4. Good. So it wants to know how long our short leg is and how long the other two sides are. What in the world could we do? It wants to know the short leg and then the other two sides. So we've got to solve for x here. Oh, we need something to set it equal to. We could, how do you get 0? Where's that coming from? We can't just write some equation and make something up and say it equals 0. I don't know. Do y'all remember the Pythagorean theorem? Do y'all remember a squared plus b squared equals c squared? That's your Pythagorean theorem. So that's what we're going to have to use to help us set up an equation here. That's got our equal side in it, right? Do you remember which is C? What side is C? Your hypotenuse. It's your long side, yeah? So we'll do our side squared plus your hypotenuse squared. So for your short side squared, that was just going to be x squared. Plus, when we do b squared, you're going to have x plus 2 all squared. When we multiply that out, what do you have to use? X plus 2 all squared. How do you multiply that out? The box. You have to use the box. You cannot just give everything a squared, right? Didn't we learn this lesson on that test when every one of us missed that problem? You've got to use the box, yes? And then for c squared, we're going to have x plus 4 all squared. So again, what do you have to use to multiply that out? The box. Are we good at using the box? So I'm going to tell you what you get from those. We're going to have x squared plus 4x plus 4 when you multiply out x plus 2. When we multiply out x plus 4, you're going to get x squared plus 8x plus 16. That okay?
What is the next to equal sign? What is that?
X squared plus 8x plus 16. Sorry, that's like super small up there. I'm sorry.
You said it so fast. I was like, what?
So,
16x plus 12?
no. X squared, come down. From x plus 2 all squared, you get x squared plus 4x plus 4 equals. Then the x plus 4 all squared, you're going to get x squared plus 8x plus 16
Oh, that's the x plus 2.
in the picture. Yeah. Is that okay?
Yes.
Yep. And that would be what you get from the boxes. I just didn't do out the box. Is that all right?
Yes.
Any questions there? Okay. So when y'all are doing this on your own, you'll do the boxes and you'll get the same things there. So what should we do from here? What do we usually want it to equal? What do you usually want it to equal? 0. So we need to move all this stuff over here. So we're going to minus x squared, and I'm going to put a minus x squared below another x squared. We're going to minus 8x. I'm going to put that below the 4x, because those are like terms. And then we're going to minus 16. I'm going to put that below the 4, because those are like terms. Does that make sense? So you're just writing it under the like terms that you've already got. So the x squareds here are going to cancel, and we'll have that 1x squared come down. Then we've got 4x minus 8x. What is that? And then you have 4 minus 16. What's that? Good. So you got negative 12. All this equals 0 now. Are we okay? Everybody still with me? You writing this down? So we're equal to 0. What do we have to do to start solving that? Factor. Now, is there a GCF? Nope. No GCF. So we are going to try to drop it low. What do you drop first? What do you always keep? Second sign's a minus. That means these are opposite. You're looking for factors of 12 that subtracted before. What are they? 6 and 2. When we solve from x minus 6, what do you get? From x plus 2, what do you get? So does it make any sense for us to have a side length of a triangle that is negative 2? So what are you going to do with that answer? Throw it out. What's our x going to be? 6. So that is the short leg. Do you agree? So how long is the short leg? 6. And it's in centimeters, so we can add that. Then it wants to know the length of the other two sides. So your other leg was x plus 2. So what is x? If you weren't sure, we can go back in and label our picture. So x was what? 6. So I'm going to put a 6 on this side. What is x plus 2? So 6 plus 2, 8. And then 6 plus 4, 10. Which of those numbers is the smallest? That's your short leg. Does that make sense? Okay, so then the other two sides were what?
8.
Is that okay? Do we have questions there? All right. So number 6 is the same thing. We're going to do it too. Okay. So you have a long leg of a right triangle that's 5 centimeters longer than the short leg. What should we do right now? Draw your triangle. A right triangle specifically would be helpful. It says the longer leg is 5 centimeters longer than the short leg. Do we know anything about the short leg? So what are we going to put? X. So then your longer leg, how would you write it? Yep. For the other leg, it's 5 centimeters longer. How do you write that? X plus 5. Your hypotenuse is 10 longer than the short leg, so how are we going to write that? Is that okay? All right. So what formula do you use to help set this up? The Pythagorean theorem. A squared plus b squared equals c squared. So I'm going to use a separate piece of paper to get it a little bit bigger for y'all to see. So our a squared would be that x squared again. So I'm just going to have x squared plus b squared. What is our b? X plus 5. And then what was our c? X plus 10. Remember the c is going to be your hypotenuse. Is that going to be a little bit easier for y'all to see? Hopefully. Okay. So the x squared, we can just bring that down. How are you going to figure out what x plus 5 squared is? Do the box. When you do that, you get x squared plus 10x plus 25. Are y'all noticing a pattern for that yet? What do you do to 5 to get 10? What do you do to 5 to get 25? Times itself. So look back when we did the other one from x plus 2. What do you have to do to 2 to get to 4? Times 2. From 2 to get to 4. Times 2 again, or square it. Does that make sense? So that's your pattern, y'all. So when we go do it for x plus 10, let's see if you can figure it out. You're going to have x squared. What's our middle term going to be? Where'd you get 20 from? 10 times 2, so 20x. And then what's our last term going to be? What do we do to 5 to get to 25? Times by itself, square it. So 10 times by itself or squared gives you 100. Is that okay? So if you can memorize like those rules, that's going to help you not have to do the box. I think it's a little bit easier. If you don't want to, you don't have to. The box will still work every time. What do we need to do from here? Move everything over. So we're going to minus the x squared, and I'm going to put it below another x squared. Then we got a minus 20x. So I'm going to put that below our 10x because they're like terms. Then we're going to minus 100, and I'm putting that below 25 because they're like terms as well. Is that okay? So whenever you're moving that stuff over, just put it below your like terms. What's going to happen with our x squareds? They cancel, but we still have the 1, so I'll bring him down. Then we've got 10x minus 20x. What does that give you? Negative 10x. Then 25 minus 100. What is that? Negative 75. All this equals 0. Is that okay? Alright. So we have got to figure out from here, what do? Factor. And we're going to need factors of 75 that subtract to be 10. Can y'all think of any off the top of your head? I'm kind of drawing a blank right now. So what could we do? What could you do? 15 and 5? If you couldn't come up with that off the top of your head, where could you look? On your factor sheet that you also have, you still have that, or go in your calculator. Okay, so I would have gone in the calculator just because I have it right here. But 15 and 5 will get us there. Is that okay? So we'll put the 15 first, and then the 5. When we solve x minus 15, what do you get? 15, and then x plus 5? Negative 5. Which answer can we throw out? The negative 5, because our triangle is not going to be negative 15. So we know that x equals 15. So I'm going to go back in and label the sides of our triangle. So the x side is 15. Then the other side that was x plus 5, what's that one going to be? 20, because 15 plus 5. And then our hypotenuse, we had x plus 10, so 15 plus 10. 25. So what is the shorter leg? 15. And what are the other two? 20 and 25. Is that okay? Do you have any questions? Do we need to go back and do number 4, or are we all right with all those? We're good? Awesome. Okay. So we're going to do some practice.